Welcome to Chemistry in the AM. Joel Shadelka coming to you on this frosty day. I only asked you to do 3 and 4, right? So let's just take a look at those real quickly because I shortened them. Do I need to go through number 3? Or as 3? Because I can go into it more deep. I'm not saying anybody would need to. See, I skipped 1 and 2 because it's more of the same. I want to do number 4 for sure, though. I'll just take a look at it a few steps at a time. I don't solve it at once. But essentially, first you have to take the name iron 3 phosphate and figure out what the formula is. Iron with, or I said iron 3, it's iron 2 phosphate. Okay. So, you got to figure out the formula. Why? Well, you look it up on the chart. 2 plus, 3 minus charge. So that means this is your formula. It's the solid. It goes on the left side. Double arrow, because this is equilibrium. Associated in water. And so when it associates, it separates into its ions. Cation is 3 groups of iron, 2 iron. Put the AQ down. I'm going to be looking for AQs and S's. Right hand side, you always have AQ. Dissociation also leads to 2 groups of the phosphate ion. So you have that 3 minus. Now, the kind of algebraic logic. One group of this splits out. You're going to have 3 groups of iron, 2 groups of the phosphate ion. So we say S groups of the iron 2 phosphate split up, dissociated. We're going to have 3 times S and 2 times S, respectively, for iron and phosphate. Right? That's I think. Whether you explicitly write that down, that's how well you say, well, the K expression for that is written. Oh, that's going to be easy. Phosphate 3 for the Q squared for the phosphate. And we put in our algebraic expression function, 3s and 2s. This is now called SP, solubility product. We're actually going to cube the 3s cube and square the 2s. You notice, though, this is the shortcut for people who start noticing patterns. If it's 3s, it's automatically cubed. If it's 2s, it's automatically squared. If something was, and it's not going 7s, it'd be to the power of 7. We're not going to do that. Yeah. Cube 3, it becomes 27. And then s cubed. So that's where this comes from. You square the 2, it's 4. When you square the s, it's s squared. So that's where those come from, right? People have different abilities. 3 different math courses you can take. Problem solve. Depends what you take and how familiar you are with squaring the cube. When you multiply the 2 with 2700, or you put the numbers, s cubed times s squared is the s cubed. I'm going to get you guys to try this calculation problem. So jot this down and we will work through it. And then we'll follow up with some actual problems to try. I'll pause the video so that you can jot this down. So, calculation problem. I've got sodium phosphate. And it's solid. It's separating into its ions. 3 sodium ions, 1 phosphate. Okay. Call the concentration of sodium phosphate in a saturated solution. Solubility of sodium phosphate. You can't dissolve more than that. And that's always at a certain temperature level, but we're going to just assume I'm giving it to you a room temperature-ish. I'm saying 20 degrees. Room temperature varies, but it's generally around 20. 20 degrees, 12-gram sample of sodium phosphate with 100 mils of water. I haven't actually given you the moles per liter. So, first thing, what's the solubility in moles per liter? Then we'll get to KSP business after that. So if I've got grams, I need moles. And if I've got mils, I need liters. Now the mils to liters, I think, is pretty easy, right? Again, I have it up here. 1,000 mils at the top. I mean, if you need that, exactly. But I'll point. So I really don't need to do an actual calculation for this one. 100 mils, divide by 1,000, move the decimal 3 times. A lot of mils is a small amount of liters, so use your common sense. Let's divide. 0.100 liters. That part of it I can do in my head. I don't even explicitly need to write it. I'm doing it. A, solubility in moles per liter. 12 grams. Sodium phosphate, Na3PO4. So I'm going to have to look up, add up Na3PO4. But first, before I do, I'm going to just put my units in here. I've got grams on the top, 12 grams. I want to get rid of grams, so I put them downtown. I know how the periodic table works. If I look up 1 mole, or I mean, if I add up the grams, that's the grams for 1 mole. So the number on the bottom is what I'm going to figure out. So we go 3 times the mass of Na. And you're going to use that periodic table that I give you. Always add 22.99 times 3, plus 1 group of phosphate, 30.97, plus 16 times 4 for the oxygen, right? Now I'm expecting. Hopefully I use the same periodic table when I do. 163.94 grams. That's what I added. And I'm assuming you know how to use your calculator. I'm assuming you know how to calculate moles. 0.0732. I'm going to put the chemical down. Okay. I'm big on units and the chemical it provides. I've converted to moles. I need the moles in a liter. Up top, we said 100 mils is 0.1 liter. And I put 100 because I'm going to assume that 100 mils was the key significant data. I made the problem, so I didn't really indicate that there. So the concentration. Now I'm going to call this S for solubility, and this is the S that we're going to talk about the very end. Okay? So the solubility of sodium phosphate. Take the grams or the moles and divide by the liters given. So mathematically, let's just slip the decimal around. I can put big M, I can put moles per liter. I'm going to put moles per liter as that's sodium. It's specific to that count. This is why we're doing expressions with acids as compared to solubility. Solubility product. So B, what's the Ksp value? Before I go on though, do I need to clarify? Okay, well, let's just double check this. Not trying to make a mistake. So let's just double check. Three groups of Na, so 22.99 plus one group of P phosphorus, 30.97, plus 16 times 4 for ours. No, the phosphate is 1 P. Just a second here. No, I got it. Yeah, this formula is correct. So I just repeated this in my calculator. Okay. Okay. So if you tend to get wrong answers on there, do it in the margin and write down little chunks 3 times 1 plus. Actually, like maybe write them up. Okay, the KSP value, that means I need the KSP expression. That means I'm going to go up to the top slide. I'm going to do it explicitly like every step. If you want to skip straight to the KSP expression, I'm fine with it. Now, S solid does not appear, sodium phosphate. So it's really just Na cubed, CO4 to Na. I'm going to write this out. You don't necessarily have to. But first, let's say KQ. Put my aqueous items in there. This is what we were doing yesterday. And I'm going to slide up and just take a look. If you want and it helps you, you don't have to do this. You think, well, if one of these breaks up, even though it's salt, it dissociates in the water, you're going to have 3 of these and 1 of these. If S moles of that break up, instead of just 1, we're going to have 3 times S, 1 times S. I'm going to put that into my KSP expression, or make my KSP expression. However, we've done these a few times, and I mentioned this earlier. If it's cubed, it's going to be 3S, but that's the reason why. And then this will be just single S. Okay. So I can do the cubing in my head, I think. 3 times 3 times 3. 27. So the number is 27. Actually, I'll do it in 2 steps. 27 S cubed times the single S. 27 S to the 4. That's my, well, I put an equal sign without putting what this was. KSP. My KSP expression is 27 S to the 4. I'll write this KSP. Don't necessarily need to, but I'm using this. Now, that doesn't quite solve the problem. The KSP expression, not the value yet, but we have an S value. Have it in red above 732. All we're going to do is put it in here. KSP value now 27 times 0.732. As long as that was in moles per liter, big amp, something like that. I do not use my units, just like you pay equilibrium calculation. It's to the power of 4. I want you guys to check out on your calculator. Different brands do it differently. You might have a Y to the X button, you might have an arrow up kind of exponent button, different brands, different ways. I'm going to wait, see what you guys get. We're getting 7.75. Just a game. All right. Not decimal places, I want 3 important digits, 3 significant. because the red measurement was 0.732, 3 digits in there. Okay. All right. I've got something for you guys. I'm going to hand this out to you. I'm going to do one of them as an example. So we're going to work on these problems. Now I'm going to just mention something, guys. On these problems, I'm going to do number 2, an example. But first, about number 1, these ones I've given you in grams in 1 liter. So that, you know how I get it in 100 mils before? This one's already in 1 liter. So you just change grams to moles and divide by 1 liter. So as far as the first step, that's how that one differs a little bit. Okay. And then you calculate the Ksp value for 1 kb. This one, they're both in grams per liter. If they're already in moles, then it would be really easy. So I'm going to just erase something here. Now, I'm going to ask you guys, last semester, you obviously picked C. 2AB or C. I'm going to work through, this one is one where the Ksp is given. You have to find the S and then figure out that. Which one do you guys want to do, A, B, or C? I think C might have been chosen because it has the most exponents, but I don't really care. C? Sure. We'll do C together. And let's see here. I'm giving you the chemical formula. I could have given you the name silver carbonate. And that would have meant you'd have to use your iron sheet to look up silver and carbonate, figure out what the formula is. But this one, okay. So here we go. Ag2CO3, solid. So here's what I'm looking for. Don't deviate from this because this is how you get full marks. I'm going to give a mark. I'm going to mark for the proper chemical equilibrium reaction. So this splits into 2 groups of silver. And it's aqueous on this side. These are all added to water. And 1 group of CO2 minus aqueous. At this point, you might be thinking, I'll just put it in a color, different color. Okay, if S groups of the silver carbonate split up, I'm going to have 2 S groups of this, and 1 S group of this. That's just my thinking step. You don't necessarily have to look at it. Now, as far as the K expression, K, if you want to do the KQ, it's Ag ion squared CO3 2 minus. And then you could skip, if you wish, said, we've done this enough that you probably see the pattern. That Ag2 plus is going to be a squared thing with 2s inside. So I'm going to put 2s squared, single s, okay? But if you need to do the full steps, go ahead. This is 4s cubed. 2 squared is 4. S squared times single s is s cubed. That's my Ksp expression. On this problem, I gave the Ksp value. And we're going to have to find solubility and the concentration of these diamonds. So here we go. 8.46. I'm replacing the letter K in Ksp. 8.46. Minus 12. We won't use units until we finalize our answer. 4s. Then what? Well, you've got to get the s cubed below. I divide both sides by 4. I'm going to keep all the digits. Actually, 2.115. There's the minus 12. Yes, I divided by 4. So that's the algebra there so far. Don't do too many steps at once. Some of your calculus might be used for this. If you make a mistake, it's better to show more steps in case you ever make it. I'm going to just left, right, reverse things. Yes or no?
Is that 5 cubed or is it
That's an S. S cubed. I've mentioned that before. S isn't a good variable because I make my 5s. So to undo a cube, you have to do a cube. So I'm going to put a little 3 in the mesh, you know what I'm talking about. That's the only way to undo a cube. If it was a fourth root, or power 4, you do a fourth root. If it was just squared, you do a square root. Everybody has a square root button. Different calculators. Some have a cube root button. Some have a check mark to the X button. You might have to do this. This button. And then you have to say it's 3 in the niche. I'll give you guys a second to figure that out. I'll pause the video. What I hear is that it's correct. 1 point, I'm going to do blue. 1.28 times 10 to the minus 4. Now, I'm going to do something here, though. I'm going to now put my unit in because I'm done calculating. This is a solubility, and it should be in moles per liter. So I'm going to use a big M, or I could put moles per liter. I'm going to use a big M. Why did I only go to 3 digits? Because I started out with 3 digits. I can't put extra one here. You could have just said 2.12. I don't know. I just did it. But I knew it's the final answer. I'm not quite done, though. So that's the solubility. I'm going to slide up and reread the question. Find the concentration of the ions in such a phase. To calculate the solubilities, done. And then the ions. Sometimes they're the same, sometimes they're not. But that S, I'm going to do this one in green. Ag2 plus the concentration of this. So I put it in square brackets because that means I'm getting concentration. Now, up here, we said that the concentration of Ag2 plus is given by 2 times the solute. So I'm going to go 2 times that S. Whereas the carbonate is a single S. So Ag is 2 times 1.2 times 10 to the minus 4, which is equal to 2.56. Moles per liter. Whereas this carbonate is a 1S, so there's no calculation required. So up top, we said it's a single S, it's the same thing. You gotta listen. That problem